All right, so this week it was a pretty big week for us. You know, first week since the game release. We did have an initial idea that we talked about and met about on Tuesday, but by Thursday, the Rust Hounds RI 3D team they released their design, and we thought there it is, pretty good test data. It looks pretty competitive, and we thought it would be a better option to shift to that compared to what we had. So that's what we did on Thursday. We talked about everything that would be everything that all the characteristics of their design, and then we also talked about like what we would add to our design. And this is what we have so far. This past Saturday, for me, it was mainly a CAD day while everyone was there, but we did print out. One of our mentors did print out this claw piece, which they call it the Y bone, and we did attach it to a piece of box tube, and it did work pretty well. We had different geometry wheels, but that's something that we can obviously change in the future to match the Rust Hounds design. And then we also kind of finalized the dimensions of the elevator. The placement on it is still kind of up for grabs. We don't really know exactly. We know a general direction on where we want to put the elevator, but there may be a couple variations, an inch or two difference. It shouldn't be too big of a deal because it's still, in essence, going to work the same way. But that's something that we're going to get to when we put everything together. Yeah, this is what we have. This is a continuous elevator. The plan is we're going to match their design as closely as possible. The thing about this elevator is that it's an inch wider. It's just an inch wider than the Rust Hounds design, and that's because the way our drivetrains are set up, obviously they had a Kitbot drivetrain, and it had the bracing that went across the drivetrain was really wide, whereas we have our max serve, and the bracing can't really go that wide because of the modules. And so I already maxed out how wide the bracing is going to be. This is as wide as the bracing can go, basically. And I realized the dimension was really close, but if we try to match theirs, the holes wouldn't line up, and it would just be a really big headache to try to build. So to simplify it, I just went ahead and made it like this. So it's going to be an inch wider, but that shouldn't change how the elevator works. I also assembled these parts together, the carriage. These parts are what the Rust Hounds did. We did also laser cut two of these plates here that we would make for this. Hopefully we can assemble that this week. The plan is to make basically this whole carriage assembly and see how that works, and then build the outer frame, and then build the inner stage. We did realize this is going to be one of the things we realized about this design is this is a lot of metal. I mean, this outer stage alone is going to be many pieces of brand new tube that we need to cut. So I guess you could say that's a drawback of this design, but we think it's definitely worth it. You'll see here I also added one of the things the Rust Hounds did on their design. I mean, it was an RI 3D, so it was a little bit scrappy. Is I read one of their notes, and it was definitely we're gonna brace the elevator. So here's my current plan for bracing the elevator. We would basically make this gusset out of either probably aluminum, maybe polycarb, and we would just rivet it straight onto the elevator to make sure it's rigid. It's also our main point of attachment here. And then I also have these big 1x1 struts that go on this side. Yeah, this part is also the same for where the coral is going to sit in. This would come down, pick it up, and then go score. We are having trouble. I'm trying to find a way to make this, where the coral sits a little bit higher, because our plan is to put a battery right on this edge of the robot, and if you see here, yeah, it interferes. So that's something I'm still trying to figure out. Hopefully, again, by this coming Saturday or even earlier than that, I should be able to figure that issue out. I also hid the climber here, but So here I also blocked out the climber. They have a very unique climb in a way that it pulls the cage into the robot. And so one of our concerns was we need a reserve space to make sure that the robot, when we design it, can actually fit the cage as we climb. So this is what this is. I copied their whole setup here. It's just a 2x1 mounted on a 1x1. And this 2x1 is basically the right length because I also read on the thread that a lot of their measurements were kind of approximated, so they didn't have super precise measurements. So I kind of went with what made sense in my head, and especially if we're using MaxTube, I also did factor that in and see, okay, this would make sense for MaxTube, or it would not make sense to cut with MaxTube. Yeah, and in terms of the funnel, we had the idea that it would maybe a good idea to make the funnel pivot, because in the case that we have a jam of some sort, or even when we want to climb, we can just deploy the funnel, pivot out of the way, and have a completely open robot. It's going to be easier to climb, and it may help with CG. And obviously, if we have a jam, we can throw a coral out. In terms of the algae intake, I've handed that off to Lamar, and they have a couple members who are working on it. One thing I would like to note about the algae intake is that it is basically completely passive. I read on the thread here, they say it's basically just powered by gravity and has two strings that retain it, and the interaction between outtaking the algae into the processor kicks the whole arm back, and then it deploys again. So we can look at it here. And you see there, the action of it outtaking the ball actually pulls the arm back, which is pretty clever. And they did say that motorizing that arm could be an upgrade, but if we have, I think we should probably motorize it. It would make sense, but we know that it could work even without it. And another thing that I'm still trying to figure out here is the way that they mount this arm. You see, it's kind of just the motor's kind of just floating, and it's not super detailed. But I did ask on their thread, and they said they would, when they get back into the shop, they're going to take photos so we can get a better look at it. An interesting thing that they did here was the way they mounted this. At first, I was really confused as to why they did this, but it kind of makes sense now, because they needed to make sure that the arm is spaced out correctly. And the way this works is, because this is a dead axle, this hex shaft is a dead axle, they need all of these three parts to rotate all together. So what they did was have two pulleys here, have a 3D printed cushion or pillow, they called it, and have the drawback to this is that you would need to have like 4-inch screws, because the screw needs to go from this side of the pulley to this side of the bearing block. So yeah, you'll see here it's 3.64. So you need a 4-inch screw, which isn't ideal, but I don't think it's going to be that big of an issue. It's just something that we need to look at carefully. In terms of how I want to rig up the elevator, I might just copy theirs. I think they have a pretty good system on a way to rig it up, and I think trying to change anything is going to be too complicated, or it's going to be too risky. And yeah, I think that's about it. In terms of the funnel, I've started kind of looking at that, and I made the first piece of tube stock of where the funnel would be, and yeah, this is currently in development. There's not much here, but I'm working on it, and yeah, that's about it.
Do you have the sketches of the reef to show kind of the different levels it can score on?
Oh yes, I think it's in. here we go. This one. So here's what I made yesterday. This is also one of the parts that I'm worried about. Is I measured on their CAD. They show 1 point. They don't really show like the max distance or their scoring position for certain levels on the reef. And so I just measured the pivot point and the measurements between the front of the drivetrain and the off the ground. And this is what I ended up with. You'll see it's not, it doesn't look very good. And so it's definitely something that we could look at, whether that means we shorten the arm or make changes as to how we score. It's just something you have to look at kind of carefully. But you see L2 and L3, these look fine. Then again, we don't know if this is the max. I don't know if this is either their L4 scoring position or their max. Because I know they did have some sort of leeway on how... I know that their max isn't necessarily their L4 position. So that may be something I need to ask them soon. But yeah, this is what it would look like against the reef. Another thing I forgot to mention is that this robot is extremely close to height limit, at least for a starting configuration. If I go from the bottom of where the floor would be to the top of the elevator, we have a 1/4 inch of tolerance, which I don't know how I feel about that. It shouldn't be that big of an issue, but in the case that we do, we may need to shave off inches on our elevator or shorten it somehow. So it's not something to be concerned about now, but it's definitely something we need to be aware of and make sure our build quality and our build tolerances are fine. So yeah, I think that's all I have for this design so far. These pivot points for L2 and L3, I kind of just guessed because they didn't. I just referenced their video and saw at about what height they would score, and this is what I've drawn up. It's definitely something we can tune, and they did release code, so we could just have a look at that and say that's where they score and change according to that. So it shouldn't be. I'm not too worried about scoring L2 and L3. I feel like that's just something we need to tune. I'm more worried about going for L4 because that's one of the big changes about this design compared to our previous approach. We initially said no to L4 because we didn't see the benefit, but seeing as most of the RI3D teams have gone for L4, and we have the design that we're copying is capable of doing L4, straying away from that design or trying to dumb it down to limit its capability would be a little bit risky, if anything, and it may be just better to just straight up copy their design with some changes to geometry, and it should still be capable of doing everything we really need it to. They did show that scoring in L1 would be very you need to be very precise, and it was really difficult. So that is one of the limitations of this robot, but I think it scores L2 and L3 and L4 pretty well. So, yeah.
What do you think about L1?
Just because of how the claw is passive, and I saw it in their video, like they had to, because of how the claw is oriented, it's really hard to make it score into L1 without like the driver being very precise or like slamming it. It just seems really risky. And so unless we absolutely need to do L1, I think it's definitely something we should avoid with this robot. Because if I looked in their video, it looked really risky. It looked like the coral was about to fall off the trough. So, yeah.
Yeah,
It was just a matter, yeah.
It's a drawback of the design, and I think that's okay. So
Did they rely on the lip on the reef to make it go to L1? Is that what they're relying on? How does that work?
Yeah, they kind of, essentially what they did was they had to slam their arm into, not slam it, but they had to lower their arm so low. And they had to make it This is L1 right here. And it just doesn't look very reliable considering that's what they had to do. So it's definitely a drawback, and I think it's something we should avoid as much as we possibly can.
Yeah.
So it's unfortunate, but I think the benefits of this design doing L2, 3, and 4 kind of outweighs not being able to do L1.
Yeah, I'm impressed it even came off the way they just did that. I would have
Yeah.
thought the friction would have been too much to even get it off. So interesting.
You think powering the claw will make it like you can spit it out, right? You think that could help?
I mean, I think it could definitely help, but it's still because of how the orientation that the claw's in. I think it's just still so it's gonna be really annoying to score into L1.
Yeah.
Just
I
think of
mean,
the
I did see
simplicity.
that.
I mean, that you're giving yourself by not having it actuated. So if everything is working really well, and those are the main areas you want to score in, I would not even risk putting an actuator
Yeah,
on there. So I mean,
because
Yeah.
if the actuator fails, the rest of it is kind of can't do anything either. So
yeah, I like the simplicity approach. Try to reduce our number of things, and if it all works, even better. So what's kind of your schedule, Cedric, on where you want to be in the next few days? Where are you thinking that you can finish in the CAD? So,
I think I'm really just most concerned about this elevator. The rest of the robot is relatively simple. Obviously, the climb is also something that is kind of complex. But yeah, I really just want to get a kind of like finalize the elevator dimensions, and then if we need to move it back and forth on the robot, that's something that we can do, and it shouldn't be too big of a hassle. Um, I think I'm gonna try to by like Saturday ish. I should be able to get a funnel catted up and ready to go. Um, yeah, I think that's gonna be the next focus is gonna be trying to get funnel how we wanted to. Because I know we had discussions of raising the coral holder and making the angle on the funnel less steep. So it's something I have to look at. I don't know how we would raise this up higher. Um, yeah, I don't know. I was thinking we could just move this 2x1 onto here, but then
you
the way the arm
sacrifice
works,
your height, right? Your total height. I think that's the drawback.
yeah,
I think if it's anything, like maybe we make it lower and then we get more height. Is that
yeah.
right?
It could be, yeah. Um, I'm just concerned because if we want to put the battery there, we have this issue. But well, we can try to. I can try to move it and see what that looks like. Because
Can
in
you put the
theory,
battery on the side of the
on the side, yeah.
Yeah, is that bad?
I just don't know how the battery wire is gonna have to twist or bend because those things are pretty stiff. So
I mean, they can bend into the side, right? Like, you know what I mean?
What
it
if the
could.
battery is on the opposite side of the climber?
The opposite this side.
Yep.
The main worry I had was we're gonna have the motor controllers are gonna be facing this blue rail here, or the wires are all gonna be coming out facing the blue rail. So my worry was that if we put a battery there, it would be so close to the motor controllers that the motor controllers are gonna be really difficult and annoying to service when we inevitably have problems with them.
Yeah, I think you should come up with a few scenarios of what you like. On one thing that I think you should change is that 1x1 for the climber should be a 2x1.
Yeah.
Absolutely.
Okay.
Don't use a 1x1 because it's gonna twist, and you want to have it as locked down as possible to the frame.
Okay. We can make that change.
But battery, I mean, I think that needs to actually be your next task is figure out where the battery makes the most sense, and if it's a couple scenarios, put it in one place, put it in another. Let's kind of show it to everybody and see people's thoughts. I really want it standing up, I don't want it flat, because it's so much easier to get out cabling. And there's with this design, there's no reason to really make it flat. There's places that you
Yeah.
can put it. So I mean, you could also like turn it. It would look a little strange, but you know, put it kind of turn it into a corner if you wanted to. So
Yeah.
um, weight wise, we would have to maybe redistribute a little bit, of like where gearboxes are. Uh, I guess we technically would have like a gearbox for probably the algae intake, and that could go, opposite to wherever the battery is, that kind of thing. So
Well, I don't know if we need one necessarily for the algae intake,
yeah, we might
because
not,
it.
but I'm
Yeah.
I'm just thinking about ways we can balance if we start offsetting the battery.
Yeah.
There's a little bit of play we have, and honestly, we might just be so light that we could just have ballast offset.
Yeah. Because I did read on their posts like their robot was like 70 pounds if you don't include bumpers and battery, and even with bumpers and battery, it was like 100. I think they said it was somewhere around 100 pounds. So you still have a good amount of weight to play with and to see
I
to
guess
balance out
the climber motor is going to be on the opposite side, so that's actually a pretty good advantage to put the battery
on this
opposite the
side.
climber, because you'd have the climber motor, probably some gears, and possibly a lot of extra bolts and fasteners to make the climber really rigid, and that's going to create weight. So to keep it balanced, yeah, you could have a battery on the other side.
Battery on this side. I'll count a few of those up and see what way works best. How do you feel about the algae intake being passive? You think it's a bad idea? You think it's something we should motorize, or should we just keep it how it is?
I need to go watch some of their videos. I don't have a good feeling of how it works. Um, I mean, we've built, and lots of other people have built prototypes of active algae intake over many different years. So for just taking a ball and doing that, so we could always revert to that. There's nothing complicated about it. But if we somehow come up with a simple way, I'm fine with it. Yeah, let's see where it goes. So,
Yeah, the only thing you have to worry about with the passive stuff is you need to worry about the weight of the arms. So that's something you have to test a few times before you like be really really sure that it's gonna go down and up. Um, and then the other good thing about making it like active is you can it's harder to wedge it into a position where it can't move. You know what I mean? Because you have the poles on the side of it. If it gets like bent inwards, if you hit somebody, um, like a active intake can like try and push itself out, but a passive is just stuck there.
Yeah.
Yeah, you have to. I mean, you just have to think about it a bit more.
so when who from Lamar is doing this algae intake?
I think the person who responded to my message was Lorenzo, and then he also said Guillermo would help on it.
Okay.
And I gave them the drivetrain dimensions, the CAD for it, and the Rustown's CAD. So they should be fine.
Okay. I mean, worst case, you should just throw something in there so you have like the full dimensions, even if it's not exact, just something to kind of take up the space of whatever it would be.
Yeah.
Yeah, I
Just
put a
like a
box
big
there.
block. Yeah. Okay.
Yeah, like a trapezoid or something. I don't know, because the funnel is gonna be like in the way, right? Something like that.
Yeah.
You know what I mean?
I'm still trying to figure out why is there coral intake, or why is the coral like resting point on the lift? Why is that not just its own standalone piece? Why does that have
I
to
don't
go
know.
up with the lift? That's what I don't
Well,
get.
I think like it's right here, right? If it's the way they have their lift set up is if they put it on like the bar that's at under the lift would get in the way of the coral as it's sliding down the funnel. But I mean, I guess there's ways to just deal with that, right?
Yeah.
Um, I think that's probably what they were thinking when they put it there. I don't know if it's necessarily the best way to do it, though.
Yeah, we should put some thought into that because it seems kind of silly to have that sticking out of your lift.
It's also super low, right? Like,
Well, couldn't you
compared,
go lower?
you could go lower, but I don't.
Made a standalone?
You would need to extend the funnel because then if you keep it like if you only lower this and keep the funnel how they had it, this is going to get in the way of the coral, I think.
I mean, the only reason you would want to lower it is to make a bigger arm, right? Or
Yeah.
give it the arm more travel, which I guess they don't need to do.
So you could go longer than 14 inches, but
Yeah, you can go. I mean, even right now, you can go way longer if you want to.
and
Um,
that would add height, Cedric. So whatever. So it might be worth thinking about uh, changing the lift to be a little shorter and making that arm longer.
yeah,
Yeah.
that's a good idea. Maybe we can make it a single stage and then
No, I don't
just
know
a bit
about single
longer.
stage, but at least not feel like we're pushing the height limit
Yeah,
because these lifts tend to add a
all
little bit
over.
of, once you put them all together, there's a little bit of slop and things get a little higher depending on what kind of, if you put a hard stop, you put a couple other things, it just adds, a half an inch pretty quick. So,
Yeah, Cedric, make sure at the top of the lift, you add like a crossbar. You can't put it like in the way of the other stages, but you need to put it. If you look at the other elevators, you put it to the
Yeah,
side
they
of
have
it.
like a thing that they have like another piece of 2x1 that runs
Yeah,
across
that's
here.
very important. Or not, it'll like try to split itself open. See
Yeah.
what it tries to do. Yeah.
yeah, I'm for just trying to add all the pieces into this thing, and then once you have kind of the rough blocks of the algae intake, the battery, you think you've got everything in place, share it with everyone, and then get back into all the lift details that we need to do before we actually can assemble it and make it.
Okay.
Because we can go cut these boxes pretty quick, put them together, but then there's a lot of other detail that needs to be done, um, which is fine. We just got to think about it and CAD it carefully before we start building that.